So let's start with 3 points. Point A, point B, and point C. And if we connect these 3 points, these 3 different points with, and they are not collinear, they are not on the same line. If I connect them with line segments, I will get a triangle. And I think you're familiar with the idea of a triangle. And what I want to do in this video is prove that the angles inside a triangle sum up to 180 degrees. So if the measure of this angle is A, measure of this angle is B, measure of this angle is C, and I use lowercase a, b, and c. Actually, let me not use those since I've already used A, B, and C. If this was X, Y, and Z, I'm going to prove that X plus Y plus Z is going to be equal to 180 degrees. Now let me get those out of the way so that we clear up some space for the actual proof. So what I'm going to do is I'm going to start off by constructing a line that is parallel to line segment BC, but it goes through point A. So that line might look something like this. That line might look something like that. And I could call that line L. And let me continue this line segment BC. Let me just turn it into a line just so it looks like a nice line, so that we see that they really are parallel lines. And now let me show you that they are parallel. And so I could write here, I could say line L, I'm going to assume I've constructed line L in a way that it is parallel to line BC. It is parallel to line BC. And the reason why I do that is then all of a sudden the 2 other sides of the triangle become transversals for these 2 parallel lines. They intersect those 2 parallel lines. And in case you're wondering, hey, Sal, how did you just assume that you can construct a parallel line here? You can always, given one line, and you find a point that's off of that line, there's always a unique parallel line that goes through that point that's not on the original line. And I think you could see that just by kind of reasoning it out or kind of just visually looking at things. So what I want to do is start to think of line segment AB and line segment AC as transversals of those 2 parallel lines. So let me just continue them on so they look like real lines and not just line segments. So that is line AB. That is one transversal. And then I have line AC that just keeps going. So I'm continuing this side right over here. That is another transversal. So line AC is another transversal. It intersects the 2 parallel lines. So now let's think about some of the angles inside the triangle. So let's say that the measure of this angle right over here, let's say the measure of that angle is x. Well, we know from what we've learned about parallel lines that this is one angle between the transversal and one of the parallel lines, and there's a corresponding angle between that same transversal and the other parallel line. And it is sitting right over here. We know that the corresponding angles are equal. If this has measure x, then that is measure x. If this is 30 degrees, then that is 30 degrees. If this is 70 degrees, then that up there is also 70 degrees. Well, we also know that if that is x, then the vertical angle is also going to be x. So this is also going to be x. Fair enough. Now let's think about another angle in the triangle. Let's say that the measure of this angle right over here is going to be y. So if this angle right over here is going to be y, what is this entire angle? What is this entire angle going to be? Well, it's going to be x plus y. This entire angle is x plus y. Well, if this entire angle that I've this arc in green I've shown you, if that's x plus y, so let me write it over here, that is x plus y. And I'm talking about this whole thing. This whole thing is going to be x plus y because x and y are adjacent right there. They share this side. Then does this whole x plus y have any corresponding angles if we look at this transversal, if we look at transversal AC? Well, sure, it has a corresponding angle right over here. If this angle is x plus y, and maybe I'll draw that as a little bit neater. If this angle right over here is x plus y, then this angle right over there is x plus y. Now, if this angle is x plus y, what is, let me do this in a new color, what is this angle right over here? Well, this angle that's at this intersection, this angle x plus y, this green arc right over here, is supplementary to this magenta angle right over here. So we have x plus y. Let me do it in that same green color so you can follow along. So we'd have x plus y plus question mark is going to be equal to 180 degrees. Their outer sides form a straight angle. They are supplementary. They're adjacent angles whose outer sides form a straight angle. They're going to add up to 180 degrees. And so the question mark angle, if we subtract x plus y from both sides, question mark is going to be equal to 180 minus x minus y. So this is going to be equal to 180 minus x minus y. So now, given how we've set up the three angles, or the measures of the three angles in the triangle, what do they add up to? Well, let's add them up. We have x here. That's one of the angles, or I guess we could say the interior angles in our triangle. We have x there. Then you have y there, x plus y. And then you have this character right over here. This character we figured out is going to be 180 minus x minus y. So what are they going to add up to? Well, this x is going to cancel with this x, and then you have this y is going to cancel with this y, and you're going to see that they add up exactly to 180 degrees. So we just proved ourselves, just using what we know about parallel lines, that the angles, the interior angles of a triangle, of any triangle, add up to 180 degrees.